Good morning all. Today in this session we have discussion on cubes and cube roots. Previously we have completed square and square roots, and here it is cube and cube roots. So first look on that. Cube in geometry, it is a solid figure having equal length, breadth and height. All its sides are equal. Look this figure. Equal length, breadth and height. If you are looking for only one surface, this will be treated as a square. And now this is cube. Here we are using cube of side 1 centimeter. Now just look for the cube having side 2 centimeter. And just think on that. How many this kind of cube are possible in this 2 centimeter cube? So first, as this is 2, so this will be treated as 1. Here 1 cube, 2, 3, 4. 4 this side and 4 that side down. So 8 numbers possible. Here in 2 centimeter we have 8 numbers of 1 centimeter cube. So in place of if we have 3 centimeter, then what? How many numbers? If we are making here 1, 2, 3 centimeter, then 3 and continuously it will having 27 numbers. 27 numbers. So what are these 8 and 27? These are known as cubes of 2 and 3 respectively. Depends upon the number. If 2, then cube will be 8. And these are the number of cubes. So based on this, we can have cube of these numbers. So here 1 cube, 1 to the power 3 times. So this we will write 1 multiplied with 1 multiplied with 1, and result is 1. 2 cube, 8. So 2 multiplied with 2, 8. 3, 27. And many more possibilities are there. Just I am doing one more. If it is 9 cube, then 9 with 9. And 9 9 ja 81 9 ja 729. So in this way we can find the cube of these numbers. And these are known as perfect cube. 1, 8, 27, 64, 125. These all are perfect cube. But here for negative number we will have negative cubes. If number is -1, cube will be -1. If number is -2, cube will be -8. For the number -3, cube will be -27. Not as square. Now just look on the properties of cubes. Here also we have many properties. In the first property, to decide one's place digit. By looking the ones place digit of the number, we can decide what will be the ones place digit for the cube, and it is based on if any number ends with 1, their cube ends with 1. 1 cube 1, 2 cube 8, 3 cube 7, 4 cube end with 4, 5 cube end with 5, 6 cube end with 6, 7 cube end with 3, 8 cube end with 2, 9 cube end with 9, and 0 end with 0. This is how we are deciding the ones place. Simple example, if I am writing, if you have a number 96 cube, how to decide the ones place? So look here, what is ones place? 6. So for 6 in cube also it is 6. So this number always end with 6. For any other example, if a number is 123 cube, so here in cube the digit ending will be based on 3. So look here, 3 ending digit is 7. So in this number ending digit will be 7. This is how we are finding the ones digit. Or if we have 123 cube, ending digit is 3, so based on 3, here the number end with 7. Next property, cube of odd is always odd, and cube of any even number is always even. Based on this also we can look. This is even number, so cube is even. For all the even numbers, cube is even. For odd, we have odd. So this is, you can use any example like 25. Here the number is odd, so cube will also be odd. So by looking the number, we can decide cube will be odd or even. Now in next property, cubes are sum of consecutive odds. 1 cube, result is 1, and it is the sum of first odd number, only 1. Now just look for 2 cube is 8. This is the sum of next odd numbers after 1. Next odd number is 3 and then 5. This is the sum of 3 and 5. So same thing we can think for 3 cube is 27. This is the sum of next 3 odd numbers. For 2 cube, 2 odd numbers. For 3 cube, next 3 odd numbers. So next 3 odd numbers are 7, 9, 11. Just look, 11 plus 9, 20, and plus 7, 27. So 4 cube equals to next 4 odd numbers after 11, 13 plus 15 plus 17 plus 19. Now just next property, some numbers can be expressed as the sum of cubes in different ways. Like simply I am writing for the number 2, 1 cube plus 1 cube. We have only one way to represent 2 in the form of sum of 2 cubes, 1 cube plus 1 cube. For any number, if we have many ways to represent as the sum of cubes, then that is spatial property in the number. Here we have one example, and that number is this. For this we will discuss later. 1729. This is the special number 1729, because this number can be expressed as the sum of two cubes in two different ways. 1 cube plus 12 cube. Result will be 1729. And also the same number can be expressed as 9 cube plus 10 cube also. In both the conditions, our answer is 1729. And this is a special number known as Hardy-Ramanujan number. Due to this property only, if any number which can be expressed as the sum of two cubes in two different ways. So this 1729 is the smallest Hardy-Ramanujan number. One 1729, smallest number, and many such numbers are there, but this one is the smallest. So for Hardy-Ramanujan number, simply we are using 1729. Apart from this, we have some more examples, and in that, like here 1729, we are using only two cubes. Some numbers can be expressed as sum of three cubes. Some numbers can be expressed as the sum of four cubes. Just here I am showing the examples. The number 2, which I explained earlier, 1 cube plus 1 cube. To represent 2, we have sum of 2 cubes and only one way. Now for 1729, just now we discussed, we have two ways, 1 cube plus 12 cube and 9 cube plus 10 cube. Now we have to think for another number which can be expressed in three different ways. The number is 87539,319. This can be expressed as the sum of two cubes in three different ways. This kind of numbers are known as taxicab numbers. Taxicab numbers. This can be expressed as only one way. So this is Taxicab 1, TA1. Simply we are writing TA for Taxicab 1. What is the example of TA1? 2. The number is 2 only. TA2 expressed in two different ways. TA2 and this is TA3. Till now we have only 6 taxicab known numbers. Means here we discussed up to 3 only. We have 6 known taxicab numbers, and this is similar as Hardy-Ramanujan number. But for Hardy-Ramanujan number only it can be expressed in 2 ways, and here in taxicab 1, 2, 3, 4, 5, many more. Actually this in Hardy-Ramanujan number there is a story in between Hardy and Ramanujan, the great mathematician. In terms of Hardy, when Hardy was going to meet Ramanujan, he used a taxi with number 1729, that was taxicab, and from that only we are using Hardy-Ramanujan number for that number only, 1729, and related with that all the numbers are now taxicab numbers. And for that number, when Hardy asked to Ramanujan, how is the number 1729? It is not good. Then Ramanujan replied, no, it's a special number. This 1729 is the smallest number which can be expressed as sum of 2 cubes in 2 different ways. So this kind of numbers are now called Hardy-Ramanujan number. And related with this, these all are taxicab numbers. Now next is prime factors of the cubes. This we will discuss with the example. Just I am using any one perfect cube as 64. So to find the perfect cube, divide with the prime numbers. First, the smallest prime number is 2. Start with 2 if it is divisible by 2. So with 2, 64 is divisible in 32 times. Then again with 2, 16 times. Again with 2, 8 times. Again with 2, 4 times. Again with 2, 2 times. And finally with 2, 1 time. Your last will be 1. If you are not getting 1, just go on. So look, for 64 we can have 2, 6 times. So this is 2, 2, 2, 2, 2. In every perfect cube, you will find a prime number which will be in the group of 3 always. This is a prime number, group of 3. This is also a prime number, group of 3. Maybe same or maybe different. So 64 is the cube of this 2 into and here 2, 4. So 64 is equal to 4 cube. this is how we are finding a number, whether it is perfect cube or not. If it is perfect cube, then for which number it is perfect cube. Like 64 is perfect cube. Why? Because all the prime numbers are in the group of 3 3, and 64 is the cube of now 2. This is one number from another number. 2 into 2 is 4. Explaining with one more example. Look on, for example, next we are using 1000. Now just we will discuss on 1000, whether it is perfect cube or not. First we have to check for that. As we already know, this 1000 is perfect cube, but how to check if you don't know about the number? Again, go for prime factors using this long division. Divide by 2 500 times, again by 2 250 times, by 2 125 times. Now it is not possible with 2. After 2, which prime number we have? 3. Check whether it is divisible by 3 or not. No, it is now divisible by 5. 25 times, and then again by 5 times, and finally 5 ones are 5. So we reached up to 1. So in 1000, look here, 2 3 times and 5 also 3 times. So this 1000 is perfect cube. 1000 equals to 2 into 2 into 2 into 5 into 5 into 5. 2 and here 5. So this 1000 is the cube of 2 into 5, 10. 1000 is the cube of 10. So 1000 equals to cube of 10, 10 cube. So in this session, up to here only, and next session we will have the discussion on cube roots and some more properties. Okay, thank you. Have a nice day.